Okay, we're going to start Chapter 5 here. Chapter 5 is just a continuation of the work that we were doing in Chapter 3. We're going to be doing more proofs with triangles. The proofs just get a little bit more complicated. Okay, so the first unit here is what we call Cpctc. Truthfully, it's probably 20 years from now, one of the few things you'll remember from geometry. You'll remember that phrase Cpctc. You may not remember what it's from, but you'll probably remember that phrase. Okay, so we got this first proof here. And so it says that WA is congruent to WT, angle 1 is congruent to angle 2, and S is the midpoint of AT, like this. So you want to try to prove the triangles congruent to each other. And there's two ways you can do this. One is you can go ahead and do subs of congruent angles are congruent, or a subtraction property to get these two angles congruent, and then you can prove the true triangles by SAS. Or, I'm not sure why I gave the information the 1 congruent to 2, because you can do a reflexive down the middle there and just do an SSS to get the true triangles congruent. Okay, pretty basic from Chapter 3, but the question is, how do I go about getting this angle congruent to this angle? And the question here is, first of all, are those angles congruent to each other? And hopefully the answer that you said in your mind was yes. And if so, how do you know? Well, since you know that these two triangles are congruent to each other, these two triangles right here are congruent to each other, then we know that there's 6 parts of both of those triangles that are congruent to each other, 3 sides and 3 angles. Then all the corresponding angles are congruent to each other, and all the corresponding sides are congruent to each other. So that's why these two have to be congruent to each other. So what we'll do is we will go ahead, prove those triangles congruent, and then in the next step, we're going to say that these angles are congruent. And we're going to say it's by what we call Cpctc. And let's talk about what Cpctc actually stands for. So Cpctc stands for corresponding, not congruent, okay? Students always want to start with congruent, but it's corresponding parts of congruent triangles are congruent. Okay, so here's the Cpc corresponding, or no, congruent, T triangles C, congruent. Okay, and hopefully you can see why congruent here does not make sense. That would be basically repeating yourself there. Okay, so let's go ahead and let's use this in an actual proof. So this first proof here, angle 2 is congruent to angle 3, angle 4 is congruent to angle 5, kind of reflexive down the middle here. And hopefully you can see that what you're trying to prove here is RS is congruent to RT, so you want to get a set of triangles congruent so you can use Cpctc. Hopefully you can see that there's only one set of triangles here to really prove congruent. So these are the ones that you're going to prove congruent. And what you're going to do is you're going to do something like this. Angle 2 is congruent to angle 3, given. And you know that these are congruent because they are vertical. So angle 3 is congruent to angle 1 because vertical angles are congruent. And then now I can say that angle 2 is congruent to angle 1 by transitive property. And then once you get transitive property, that gives you an angle. You know, there's a side coming from here, and then there's another angle coming from here. So I know that the triangles are congruent. I'm sort of not writing this entire proof out because of time, but triangles are congruent, and it's going to be by angle, side, angle. And once I get that, then as a follow-up step, I can say that RS is congruent to RT by Cpctc. So Cpctc usually follows right after you prove triangles are congruent. Let's take a look at this problem down at the bottom. All right, so we're looking at the same diagram. So I'm going to erase all the information that's on here. Come on, eraser. And so now 4 is still congruent to 5. This time RS is congruent to RT. You know that it's still reflexive. So here I have the triangles are congruent to each other already by side angle side. And then you're trying to get 2 congruent to 3. Well, I know that 2 and 1 are already congruent by Cpctc. And like we said before, angle 3 is congruent to angle 1 by vertical angles are congruent. And so now I can do my transitive. So angle 2 is congruent to angle 3 by transitive. And again, normally I would be writing it out with all the numbers like normal, all the numbers like normal here. But for the sake of time, I'm just trying to speed through that a little bit quicker. The point I want to bring up here is that, you know, Cpctc in this case is not the last step. There's a couple more steps after the Cpctc. Sometimes you have to use the Cpctc information to prove something else. Okay, let's move on to the next page. Okay, we're moving on to the second page here. Another proof on the back side. And so angle 1 is congruent to angle 2. Angle 4 is congruent to angle 3. Angle 2 is congruent to angle 3, so I know that these are actually marked the same. And therefore 3 and 4 are marked the same, so they're all congruent to each other. I know that DE is congruent to CE, and I know I'm trying to prove, let's use a different color, I'm trying to prove that DB is congruent to AC. Okay, so there's a couple of approaches you can take here. The first thing you have to do when you identify what you're trying to prove here is you have to figure out which triangles to prove congruent. So in this case, I already know that these are congruent to each other. So really, if I could find that these were congruent to each other by Cpctc, then I'm in pretty good shape. So hopefully you can see that these angles are congruent because they're vertical. And so I can go ahead and prove these 2 triangles congruent, this one and this one. So this is one approach I can take to this proof. I can go ahead and I can prove that triangle DEA is congruent to triangle CEB, and that would be by an angle, a side, and then an angle, side, angle. And then I can do a Cpctc, say that AE is congruent to BE, Cpctc, and then I can do a DB is congruent to AC simply by adding the congruent segments to congruent segments, so addition property. So that's one approach I can take to this. Another way I could attack this is I could go after the overlapping triangles here. You see that? This triangle and the other one. Because I already have this angle congruent, I have this side congruent because they're overlapping with each other. They're shared between that triangle and the other overlapping triangle DCB. And I can do an addition property to get this angle congruent. Okay, so I know that angle ADC is congruent to angle BCD by addition property. I know that DC is congruent to itself because of reflexive, and I know that angle 2 is congruent to angle 3 because it was given. So because of this, I can say that the triangles are congruent. So triangle ADC is congruent to triangle BCD. It's the overlapping triangles. And then I can just do Cpctc to get DB congruent to AC. Okay, so there's two approaches you could have taken with that one. Either one is completely valid. All right, one new piece of information here is kind of a simple one, and that is basically whenever I have a circle, all the radii are congruent. So my theorem is basically radii are congruent, or if radii, then congruent. And so basically what that allows us to do is it allows us to do proofs where there are circles in them. And so you'll see stuff like this, circle Y, where that represents Y is the center of the circle. So because Y is the center, I know, for example, that BY is congruent to YU. So BY, for example, is congruent to YU because radii are congruent. And so whenever you have a circle proof, a proof with a diagram that has a circle in it, you pretty much know that you're going to probably do something with radii are congruent. Let's just quickly finish off this proof here. AYU, change the color. AYU is congruent to PYB. Okay, hopefully you see the overlapping angles there, which will give us these two angles congruent to each other by subtraction. And Y is the midpoint of AP, so I know that these are congruent to each other because Y is the midpoint of AP. Okay, so I'm going to need to do, well, I needed that circle in here, by the way, as a step prior to that, so circle Y. I need angle AYU is congruent to angle BYP, that's just given. And then I did a subtraction, right? So angle BYA is congruent to angle UYP by subtraction property. And then we did this guy is given. AY is congruent to YP. If it's a midpoint, divide the segment into two congruent segments. And now I can say that the triangles are congruent. Triangle BAY is congruent to triangle UPY by side angle side from steps, what is it, 351. And now I can jump, hopefully you can see that where we were headed with this was I can jump to say that these two are congruent. BA congruent to UP by Cpctc. Okay? Alright, so hopefully you're okay with Cpctc. Give you a homework a try.